Hello, welcome to Waka Waka Breaking It Down. Today is law of cosines. So you already should have studied law of sines, which is a way to solve for angles and sides on a triangle that is not a right triangle. Law of cosines is just one more example of that, and it deals with a very specific type of situation. So this is, I'll kind of talk about this in just a second, but I want to pop back to the law of sines, and this is just stuff I wrote on the board. On the left, we have a proof. You don't have to worry about that. The formula you're going to be given on your test, so you don't have to memorize that either, but it's not too hard, so maybe you could memorize it. So I just want to focus on, well, there's a little note down here is actually what I want to focus on. So there's a situation with the law of sines where you have two sides that are known and the included angle. So the angle that's right directly in between those two sides. If that's a situation that you know, or the information you know, the law of sines is not going to work. It won't be good enough. You're going to have to use the law of cosines. So first of all, why doesn't the law of sines work? Well, here's the law of sines right to the left of it here in red. Let's take a look. So if I were to try to set that up with this, I would have 8 over, or sorry, the sine of some angle. So let's do sine of 20. Okay, so, oh, sorry, I gotta get my pro mouse. Here we go. Okay, so if I had sine of 20, let's say, because that's the only angle I know. And the other thing I'm realizing like right away is that if I know one angle and I don't know a second one, then there's no way to find any other angle. It's like I only know 20. I have no clue what those other two are. It's you can't assume they're anything, so they could be anything. So if sine of 20, I'm supposed to use the side that's directly across from that, but I don't know what that is. So that's going to be an unknown value. And then I say, well, I can pick any side I want. I can pick the 8 or the 25. That's fine. But again, when I look for my angle, I don't know what those angles are. So I'm going to have this sine of some unknown angle and then maybe have like either 8 or 25 at the bottom. So of the four pieces, in order to solve, I need to know 3 of the 4. I know 2 of the 4, and no matter how you do it, you're always going to end up with just knowing 2 of the 4 things for this particular situation. So the law of sines doesn't work. Like there's not enough information to try and solve it using that method. So what do? Are we stuck? Do we give up? Heck no, we're mathematicians. We don't give up. We have this thing that's called the law of cosines. So let me go back. So you'll see, let me just look real quick. So you'll see on these situations, even like here I know 2 angles, so that's the law of sines is going to be fine. I just need to know one side in order to make my equation, right? For this example that we had down here, I know all of the sides. I only need to know 2 sides. Like if I knew this information, I could use law of sines. It would be no problem. But if I didn't know this and I knew these 2 sides, then that would be a problem. I wouldn't be able to use law of sines to do it. So it's real specific. It's real specific. So let me go to, sorry, I can't go over the other board. I have to flip pictures. Okay, so this is my law of cosines board. Again, the formula is going to be given to you on a test. You don't need to memorize that, although I would, right? You're becoming close to a pre-calc student and upperclassman, and it's time to really know some math and not just memorize and regurgitate math, right? Okay, so let's know some math. So this isn't too bad. Why? Well, because if you look at it, doesn't that just look like the Pythagorean theorem? Yeah, it does. It's just like the Pythagorean theorem, except we're adding on this minus 2ab cosine of c. The a and b, it comes from these letters that are right next to it. So that's these a and b. And then the c comes from the side length that you're solving for, or vice versa. So usually you're solving for a side length or you're solving for an angle. So that's what the C is, right? Either I'm solving for side C or I'm solving for angle C, one of the two, right? And then the other ones are just the other 2 sides that you know, right? So let's take a look at some examples here. So like I said before, it's a very specific situation. It's where You know two sides and you know one angle, and the angle you know just happens to be like this is the side I know, and this is the side I know, right? So that 20 degrees just happens to be the angle that's right connected to those two sides, right? It's not this one and it's not this one. It's one of those other two. So that if you have that situation, you will have the law of cosines to help you to solve it. I'm looking for the unknown side in this case, so that's this over here on that piece. I plug in my other two sides into the rest of the equation, right? A and, well, not A, but in this case it's B and C, and then over here I have 2 times B and C. And then the cosine of the angle that's across from the one that you're looking for, right? So that angle that's given to us in between those two sides. So I have to use cosine of 20. All right, so once you set it up, then it's pretty easy. It's just throw it in your calculator and you're done. Let me just point out real quick, however, like here I started talking about I'm solving for A. And some of you might say, oh, why are you solving for A? Don't you have to solve for C? And I'm like, don't get hung up on what the letters are. That's not the important piece. What's important is that the angle you know is across from the side that you don't know. So you're going to solve that way. And then you know the other two sides. That's what's important. And the side that you're solving for is the one that goes by itself. So it doesn't matter whether you call it C or you call it A or you call it B. That doesn't matter. You can label these any way you want. If you're like, I don't like A, I want to call it C. Okay, go ahead. I don't really care as long as you show me what you're doing. All right, no problem. It's just a labeling, right? It's just labeling. All right, but you just have to plug them in. What's your A, what's your B, what's your C, and just plug them in. Okay, in this case, we're solving for side length. So you can, now I know a lot of you just throw these into your calculator like piece by piece by piece. And to be honest, that's where people get lost. Like you're going to throw in cosine, you get some decimal, and then you're going to round it. And then you're going to do 8 squared and 25 squared. And then you're going to forget to put your negative on this piece. And, if you're doing a hodgepodge of pieces all over your paper, it's more likely that you're going to get lost. So this is what we recommend as teachers. And that's why you're going to see on your test, and you'll see it on the last test we took, is that we ask for what's ready form, calculator ready, meaning it's ready to just type into your calculator in one big step and get your answer and you're done. There's no rounding error. There's no averaging. There's no getting lost in all the little decimals and big numbers that you're throwing all over the place. All you have to do is write down. So I just wrote out the law of cosines. I realized that I have to take the square root of both sides to undo that. So I took the square root, right, of both sides, and you get this next line. This is calculator ready form. Yeah, all you have to do is just throw that in the calculator. Now when you use the calculator, be careful with parentheses. Like sometimes you need to put parentheses around this whole thing to let the calculator know that you're doing the square root of the whole thing and not just the square root of one piece of it. So you have to be smart with the calculator, right? The calculator is smart, but not as smart as you are, right? You're the one that needs to tell it what to do precisely. So think about parentheses when you're working with the calculator. Where do they go, right? All right, next example. This example is where we know the sides and we're looking for the angle. So very similar, but we're going backwards now. Oh, Mr. Wacha, I have 3 sides. Which one do I use? And where do I put them? Well, try to identify which side is across from the angle you're looking for. That's the first thing. Once you figure that out, then you know that that's the side that goes by itself on the other side of the equal sign, right? So that's the side that goes here, and then the rest of it goes on the other side. So the 10 and the 7.9 go here and here, and it doesn't matter if you flip-flop these, that doesn't matter. It's just addition, right? And then minus 2 times the 10 and the 7.9. You just stick those in, for A and B, whatever. You can call this C, right? And then call this A and call that B. So A, B, stick them in. Now you notice that we're looking for the angle now. So we just leave that blank, or not blank, but we leave it as a variable. Okay, and then it's a matter of solving. Again, let's get in the habit of not doing these piece by piece by piece and getting confused. Let's just solve. Now, what you need to notice on this problem is that these numbers are all being multiplied by each other, while these numbers are all being added and subtracted, are these pieces, right? So we gotta be savvy about how to solve these. So we get rid of the addition subtraction first. So I have to subtract 10 squared to both sides, which you see happened here. Then I have to subtract the 7.9 squared from both sides, which you'll see happened here. So far I would have had this, right, on the left-hand side. And on the right-hand side, I just had this piece left over. So this is all multiplication though. So now in order to get cosine by itself, I have to divide this piece off. I have to divide it. So we divide that off, and that's why you'll see that on the bottom over here. Okay, so I just subtracted, and then I divided that off. Okay, and this is what you get. Again, we're almost ready for the calculator, but I have cosine of an angle. So how do I undo a cosine? Well, you do the inverse cosine. So I'm going to do the inverse cosine of both sides of this equation. Just keep in mind, it's the whole thing that you're going to apply that inverse cosine to. So that's why you see it written the way it is down here. All right, now this is calculator ready form. It's ready to be typed into my calculator in one big step. And you please just be careful with the parentheses. If it was me, in fact, I think you have to do this. You have to put parentheses around this top part because you want to tell the calculator, hey, take all this stuff and divide it by all of this stuff before you do the inverse cosine. So you'll see that I need at least 2, if not 3 sets of parentheses in order to do that problem. Okay, so be careful with the calculator. Yeah, you got to be ready. Let me fire this up and I'll do that real quick for you. So maybe fast forward to when I get my calculator open, okay? It's really slow. Okay, so summary. Let me erase this while that's warming up. And so the next thing we're gonna go to this, right? This is the law of cosines worksheet. So that's our next thing we're gonna go to. I'll show you how to do there's a problem we're gonna solve down here, so I'll do that on the calculator. So let's get right into it. Okay, dokie. Sorry, what's this doing? Yeah, go ahead. Okay, it's warming up. It's doing its thing. All right, let me shut that down for the moment. Okay, so I've already been through all this. There's situations where you can't use law of sines, but you can use law of cosines. So let's look at these. So if I have this situation over here on the left, can I use law of sines? And the answer is yes. How do I know? Because if I have 2 angles, I can immediately figure out what the third one is because there's 180 degrees in a triangle, right? So I can figure out that that's, let's see here, this is 122. So that's 58. This angle has to be 58, right? So once I have that, then I have these opposite sides going on with angles and sides, and I can do law of sines, right? The sine of 58 over 26.7 equals the sine of 52 over x. And I would only have one variable there, so the law of sines would work. Yes. What about this situation? Well, again, look, this is that situation. If you have 2 angles, you can always figure out the third. So I'm always going to know what all 3 angles are, which means I'm also going to be able to use the law of sines. I could do like this side, let's do sine of 43 divided by a equals the sine of 99 divided by 12, right? And in that particular situation, a would be the only thing unknown, and I could solve for a. And I can do the same thing for this side c because I'll know the angle if I figure it out. Okay, so both of these situations, even at first glance, you're like, is there enough information? Just keep in mind that if you know 2 angles, you can always find the third. Okay, let's look at this situation. Can I use law of sines? Well, yes, I can because those are opposite. So I can do sine of 42 over 12. These are opposite. So, oops, sorry, those are sides. Sorry, this, I don't know. But I can figure out this angle, can't I? So if I go this way, I'm going to know both things, the angle and the side. If I go this way, I'm going to know the side and I don't know the angle. But that's only one thing out of four that I don't know. So if that's true, then I'll be able to solve for it using law of sines. So this is not one of those situations where I have to go to law of cosines. I can use law of sines. So once I figure out that angle, I could figure out this angle. Once I figure out that angle, I could figure out this side. So yes, I can figure out this side, but not directly, right? I wouldn't be able to directly do it because I don't know this angle either. I'd have to figure out that angle first. Okay, so you kind of have to indirectly get there by going through this angle first. So a little tougher, but still it's the law of sines that you would use. Okay, moving on. What if you have three angles? Well, that's nothing. I can't solve for anything here. Why? Well, this is a triangle that I don't know the size of. It could be really, really small triangle. Like I can make another triangle just like it that's really small, or I could make another one that's really big, where they're all similar to each other and they all have the same angles, but they actually have different side lengths. So you can't solve for any side lengths on this because you don't know any of them. You'd have to know at least one to get going. And you can't do it with law of cosines either. Like you don't, there's nothing you can solve for there. Okay, next one. What if I know all three sides? Can I solve for an angle? Yes, but this is that case where you're going to have to use law of cosines. So law of sines isn't going to cut it because in law of sines, if you think about it, you need two angles to solve. And in this case, I only have zero angles, right? So, or sorry, there's two angles in the formula. So you need at least one of those angles in order to solve. So I don't know any angles, so you're not going to be able to use law of sines. You could, however, use law of cosines. You do have enough information that you could just say, okay, let's solve for angle C. I'm going to call that side C, and then this becomes A and B, and then you can solve using law of cosines. So that would work for law of cosines, but not law of sines. This one, again, I know one angle, but I don't know any of the other angles. And this particular side that's across from it, I don't know. So this is that specific situation where I have two sides that I know and I have that included angle. It just won't work in the law of cosines, but it will work in the law of cosines. So it doesn't work in the law of sines, but it works in the law of cosines. Okay, so that's the whole kind of recognizing what tool to use situation, right? So here's our tool. We've already talked about that. So I'm going to skip all the way down to the actual problems. I'm going to go right to this problem. Okay, so we got two sides. We have the included angle. I'm recognizing that this is a law of cosines problem. I'm solving for this side over here, A. Okay, so I'm just going to say A squared. Remember, it starts to look like Pythagorean theorem to start off with. 15 squared plus 21 squared. And please do yourself a favor and never assume you have a right triangle from this point on. You never have a right triangle unless you are told that you have a right triangle. Okay, so I got B and C, and then 2 times B times C, and then times the cosine of 72 degrees. Sorry, I write really slow with that. And and then I just want to put that on the calculator. So I'm going to do the square root of both sides, get rid of my square, and then I can solve for A. So let's throw that in my calculator. I can show what I'm talking about. Let me open up a new computer page. Right, so I'm going to do the square root, click square root, and I have 15 squared plus 21 squared minus 2 times 15 times 21 times cosine of 72 degrees. I like to put a decimal in there so I get a, if I don't put a decimal in here, see what happens. So I like to put a decimal inside my equation somewhere after one of the numbers, so then I get a decimal out of it. Okay, so my A is 21.7. Now, again, I said before, we are close to being upper class mathematicians. So what did I say it was? 21.7? 21.7. Yeah, 21.7. So we got 21.7. And if I want to be more specific, 21.71 meters. Don't forget to put units on it. I'm getting really tired of people not putting units on things. If you leave the units off, that means I can put whatever I want there, like 21.7 eggs or 21.7 elephants or rutabagas or whatever, right? Tell me what it is. Tell me what it is. And tell me what it's equal to. Is it equal to A, to B, to C? Is it equal to the weight of an elephant? What is it, right? So start being real specific about everything, okay? All right. So that's really about it. The only other situation is when you're solving for an angle, which we've already seen one of those. I'll quickly go through that and we'll be done with this video. You'll see down here they give you this two towers situation with the cell phone towers and stuff. They give you all three sides, so you know these distances. You're just trying to look for this angle. The only thing I'll point out is that the side that's across from the angle is the 2420. The 2420 is the one that's across from the angle. So I'm going to jump to the answer down here. So you're going to see when we do the, oops, yeah, no, that was the right one. Sorry. Hmm? Oh, that's part C. What are we talking about here? Oh, 2420. This is not the right. Oh, it is. They just solved for it immediately. So they didn't write it all out for us. They did it really quickly. Um, Sorry. So you're going to see that the 2420 is the one that used to be by itself because that was the one across from the angle. And then we subtracted the 50/50 and the 6,000 from both sides of the equation. And then we divided this part over. That was the A and the B, or the A and the B. Notice that these two numbers, the ones that we subtracted, are the same ones that we are dividing by in our equation. So they got the cosine by itself, and then they did the inverse cosine of both sides, and then got 23.3. So yeah, I wanted to just point out that the 2420, so the one that's across from the angle you're looking for, that's the side length that needs to be by itself in the formula, right? That's the one that's by itself. So just be real careful of that, and then being careful with your solving and using parentheses and stuff. Like I have to put parentheses around those in my calculator, otherwise it doesn't work, right? It's not going to work properly. So be real careful with that. Okay, I think that's it. Always ask questions and be thorough. All right, let me know if you need any help.